All right, good morning. So the goal for today is to talk about equations, to talk about solutions to equations and inequalities. So I know by the time that you have reached this class, you have probably solved an equation before, but I have a little challenge for you. What I would like you to do is take a moment and imagine that you're talking to somebody who has never ever solved an equation before, who doesn't even know what is a solution to an equation. What does that term mean? If you're going to tell that person the meaning of the term solution to an equation, what would you say to someone who had no idea? I think this is a tough exercise, especially and even for advanced students who are far along in their math careers. I think the typical response that I usually get to this question is that a solution to an equation is the answer to an equation. And this is a perfectly reasonable response because up to this point, probably the only thing that you've done with solutions is that you have been asked to find solutions to an equation. And therefore, your final answer would be the solution to an equation. But as we proceed forward in our math journey, we're going to need a more concrete and more broadly applicable definition of that term. And that's the goal for today. So to begin with, I want to talk about the meaning of the term equation itself. An equation is a statement, a mathematical statement, that two quantities, even though they may be represented in different ways, that two quantities are the same number, that they're equal numbers. Now, just like any other statement in this world, an equation may be true and it may not be true, or it may be true some of the time. For example, I could give you the equation x plus 2 equals 5. This equation is only true in exactly one circumstance. It's true if x is 3 and it's false otherwise. When someone is talking about a solution to an equation, they're talking about a number that can replace the variables or the unknowns in your equation in such a way that your equation becomes a true statement. In an equation, making the equation true. All right, so let's try and use this more concrete definition of solution to answer the following question. Someone gives us a number, x equals 1, and they say, is x equals 1 a solution to x to the 7th minus 8x plus 3 equals 1? Now, it's saving us that we don't actually have to solve this equation ourselves. The big problem solving this equation is that exponent of 7 there, that power of 7, would make this absolutely devilish to solve. But what saves us is that we only have to check whether this one number is a solution. So I think the cleanest way to go ahead and check that is to say, okay, well, I should be able to replace the x's in this equation with 1 and get a true statement if x equals 1 is supposed to be a solution. So I'm going to go in and do just that. 1 to the 7th power minus 8 times 1 plus 3, is that really 1? 1 minus 8 plus 3, is that really 1? But unfortunately, the left-hand side is -4, not 1. So as a result of plugging in this candidate, this potential solution, we got a false statement. And therefore, my final answer would be that this given number, x equals 1, is not a solution. Okay, now when you're asked to solve an equation, your job then is to find to describe or to list all possible solutions to an equation. Tell me every possible way to make the equation true. Now, let's take, for example, an equation like this. X minus 3, x minus 4 equals 0. If we were going to solve this, what would be all possible values of x? Well, I think that there may be two possibilities here for values of x. If x is 3, if x is positive 3, then I would have 3 minus 3, 3 minus 4, and since 3 minus 3 is 0, that would make the entire product 0. Now, I think along the same line, x equals 4 would be a solution, because 4 minus 3, 4 minus 4, that also is equal to 0. 4 minus 4 becoming 0 will make the entire product on the left side 0. So my final answer to this question would be the solutions are x equals 3 and x equals 4. I would list all the possibilities. Okay. Now, what if you're given an object like 8x plus 2, where there's no equal sign, there's not even an inequality sign, there's just this expression here? Is it possible to solve something like this? And unfortunately, or fortunately, the answer to that question is no, it's not possible. And the reason is that an expression, since it's not a statement, since it's just an object, an expression can't be true or false. Expressions can't be true or false. And because expressions can't be true, they can't have solutions which make them true. So it doesn't make sense to solve them, because it doesn't make sense to have a solution to an expression. Okay, so let's get back into the realm of equations now. Someone wants me to solve something like 3 times the quantity x plus 1 equals 3x plus 4. Now, the typical process for solving an equation of this type is to start by distributing, to start by multiplying through 3 times x and 3 times 1. And the next sort of typical process here is to go through and try and get all of your like terms together on the same side of the equation. For example, to get all the x's together. When you try and do that, something unusual happens. 3x, take away 3x, is 0. No x's are left, which means no x's remain on the left-hand side, nor do any x's remain on the right-hand side. So this equation can be reduced to 3 equals 4. No variables left. That's bizarre, because we have been left with an equation that is false all the time. It's always false. You're never going to get 3 to equal 4. There is no way to make this true. Because there is no way to make this equation true, no matter what number you put in x's place, I would have to say that there are no solutions to this equation. There is no way to make this equation true. Now let's compare that case with something like this in the next example. 4x minus 3x. My goal is to make that less than or equal to x plus 8. Now, questions of this nature typically begin by combining like terms. For example, 4x take away 3 of those x's becomes just a single x on the left-hand side. Now, once again, if I try and combine my like terms here, if I try and gather them all together, I'm going to run into a situation where all the x's on the left-hand side and all the x's on the right-hand side completely cancel out. And I'm left with a statement that has no variables in it. 2 is less than or equal to 8. Now, unlike 3 equals 4, this statement is true. 2 is less than or equal to 8. And this statement is true no matter what. This statement is true no matter what value of x you choose. Now, because this statement is true for every x, for any x, this means that all numbers are solutions. All numbers are solutions, because all numbers are capable of making this equation a true statement. This statement is always true. So be on the lookout for extreme situations like that.